Hey guys, and welcome to question 2 of this Further Pure 1 AS Further Maths paper. So this is the Edexcel specimen paper, and this is question 2. You might have seen this before, you might not, but it's good revision anyway. So this is a differential equation, where you're trying to approximate using numerical methods. So it's numerical methods as the topic. And it's one of these questions in context, we've got someone who's trading on the stock market, and this is the price of a stock. And it's modeled by this differential equation. So it gives us a bit of context. The trader purchased £300 of the stock 1 hour after the opening of trading, and we're asked to use 2 iterations of this approximation formula here to estimate to the nearest pound the value of the trader's stock half an hour after it was purchased. So the first thing we need to know is, and it sounds silly, but the value V is in hundreds of pounds, right? So what we need to write now is what our V0 is. Sorry, I'm losing my voice. This is how bad this question is. V0. So this is the original value of the stock, right? When it's, it's first bought. So that's going to be 300, but because we're in hundreds of pounds, that must be 3, right? And then what would be T0 to go along with this? So T0. So this is 1 hour after it's opened. So T0 must be 1. Right? So that's my T0. Now, we're also going to need a T2 and our H. And the reason it's T2 is because, notice that we're asked to use 2 iterations of the approximation formula here to estimate to the nearest pound the value of the trader's stock half an hour after it was purchased. So, my H is clearly going to go up in it's going to go up in 0.15, right? Because it'd be 15 minutes. That's a quarter of an hour. So my H, so that 0.15 or 15 minutes put into, it would be 0.25. So H is 0.25. So that is my T2. So my T2 is 1.5. That's what we're clearly looking at. What is it when it's half an hour after? So that's going to be 1.5. So we've got the preliminary information that we need. All we need to do is start using the iteration formula. So let's put it into here first and get our first value. So dv by dt. So dv by dt, we have our first lot of information. So what we're going to put in here now is this line here, the V0 and the T0. So V squared, that's going to be 3 squared, minus T, so that's just minus T0, so that's minus 1, divided by T squared, so 1 squared, plus T times V. Well, T times V is just 3, so 1 squared plus 3. So if we simplify this, what we're going to get, so that's 9, 3 squared is 9 minus 1, so that's 8, divided by 1 squared, which is 1 plus 3, so 4. And that gives us 2, right? So we've got that value of 2 there. Now all we need to do is work out the new V1, right? So how do we work out the V1? Well, notice this formula here, this is the iteration approximation formula. So to work out V1, so imagine this is not Y1 but V1 and V0. I'd have to just do a bit of manipulation, right? So this would be dy by dx times H plus y0. All I'm doing is rearranging this to get it in terms of y1. So I times across by h and I add y0. So therefore, v1 is going to be approximately, it's just an approximation, approximately, it's going to be dv by dt 0 times h plus v0. So that's going to be 3, because that's my v0, 3 plus h times this value here, so h, which is 0.25 times 2. So 3 plus 0.25 times 2, that's going to give me, oops, that should be an approximation, roughly 3.5. So that's my first V1 value. So now, all we need to do is do it again with this formula here, dv by dt, plugging it back into with my new V value, and then just doing one final iteration. So if we plug it back in here, dv by dt, what's this going to be? So v squared now is my 3.5. This is my V1. So this is the new value that's going into this differential equation. So 3.5 squared, 3.5 squared, minus t, so this is this now, t1, so we're going up in 0.25, this is going to be 1.25. So this is the t1 that's going into here as well, minus t, so this is minus 1.25. Divided by t squared, so 1.25 squared, minus 1.25 squared, plus tv, so 1.25 times 3.5. So my writing's a bit scruffy, it's a bit too early for me. So this is 176 divided by 95. I've already done the calculations for you, but you should get 176 divided by 95. And now finally, we just need to do this again with V2. So therefore, V2 is going to be approximately. So remember, this formula is just a rearrangement of this. So this would be d1 by dx of 1. So it's going to be times by h, and then we add y0, or what's going to be you know, our original v0 here. So this now technically is v2 and v1 for us. So v2 is equal to dv by dt of 1 times by, you know, your v1. So if you do that, alright, just so it's clear, so that's v1 plus h of dv by dt. So I just don't want you to be confused, so alright, it might make it a bit clearer. So we're just plugging in this formula now. So this is going to give us 3.5, my v1, 3.5, plus h, which is 0.25, plus 0.25, of our dv by dt at 1. So this is 176 times 95, or 176, sorry, over 95. So if you work this out, what you actually get is 3, this should be an approximation, sorry, 3.963. But remember, V is in hundreds of pounds, so therefore the value of the stock, of the trader's stock half an hour for its purchase, so we'll just call it V, I guess, for value. That's going to be in hundreds of pounds, 396 to the nearest pound. 396. So quite a standard one. You just got to be very careful with the rearrangement. But if you're okay with that, it's quite a nice question to open with. So full 6 marks for it, and there we have it.